Hello, this is Mr. Ensler, and I'm going to be going over the Chapter 11 review, Part 1. As the directions say, we're going to find the indicated measure. We're going to give both the exact answer, which usually has a pi left in it, and we're also going to give the approximate answer. If you ever get those mixed up, the thing to remember about exact and approximate is that approximate means that you're going to round, and usually involves a decimal. Exact means you're not going to round. So if you're looking for an exact answer, don't round. And since we're dealing with circles, that might mean your answer might have a pi in it. And lastly, use correct units. If it's labeled, use that label. All right, find the circumference. We actually have two formulas for circumference. You can look them up in your packet. The one that I would use here is pi times diameter, because this 13, you can see by the way it's placed, is the diameter. So the circumference is just going to be pi times 13. Usually we'll write that with the 13 in front though, so 13 pi. And I'll put a label on that. Circumference is just a length, a distance, so just inches. That is the exact answer. Now if I reach for my calculator and type that in, I can round this to one decimal place and I get about 40.8 inches. So the exact answer I listed first, where I did not have to round, but I did leave pi as part of my answer. And then the approximate answer is 40.8, and that's where I did have to round. Alright, here they're giving us the circumference, and they want us to find the radius. And this is going to involve knowing the other formula for circumference, 2 pi r. It's really the same formula because 2 r's equals a diameter. So 2 pi r. Alright, so I'm just going to substitute 65.98 in for c. And then if I want to know radius, I'm going to divide by 2 pi. Now you can either divide by 2 first and then pi, or you could divide by them both at the same time. Now if I'm going for both an exact and approximate answer, I probably do want to just divide it by 2 first. So I'm going to type in 65.98 divided by 2, and I'm just going to leave that pi there for a minute. I'll get r equals 32.99. I didn't round, that's exactly what it equals, over pi. And so that would be centimeters. And so that would be my exact answer. If I wanted to get an approximate answer, well then I would actually type that in, 32.99 divided by pi, and I'll make the little wavy equal signs, and I get approximately 10.5 centimeters. We've talked about how both the exact answer and approximate answer have value, and we sometimes will only use one, but for this and for the test I want you to be able to do both, so be prepared to do both. Alright, find the circumference. I'm going to use 2 pi r, because 7 is the radius, so that's 2 pi 7. If I just multiply the 2 and the 7, I get 14, and if I don't want to round, that's all the farther I can go. 14 pi centimeters. Now if I actually enter in 14 pi into my calculator, I get, oh this is interesting, I'll write this out. I get 43.98229. So by this point, you should definitely know how to round correctly, and that is worth correct points. So I look to this digit here, and that tells me whether to round up or down. It'll round up, so that actually is going to affect this one also. So your approximate answer should be 44.0. And yeah, we do want that 0.0 there. The reason why we write that in is it shows that it did not come out to exactly 44. It shows that we had to have rounded. Alright, here's another one, kind of like that. Circumference is 2 pi r. This time they're giving us the circumference as 48. Actually, this problem is a lot closer to number 2, which we did. So to get the r by itself, I'm going to divide by 2 pi, but I'm not actually going to divide by pi yet because I want to get the exact answer first. So 48 divided by 2 is 24, and so my exact answer is 24 over pi. And now if I actually divide 24 divided by pi, and I'll round this, I get 7.6 inches. Again, make sure you are labeling all of your answers and you're drawing the correct types of equal signs. All right, next up, we're talking about arc length. Find the arc length of AB. So visually what that is it's this distance right here. If we could measure that with a string and then pull the string straight and put it up to a ruler or a yardstick or something, that's what we would do. That's not a very exact method though, so we're going to use the exact method. And the basic idea is that you're going to compare that arc length, and you have this formula in your packet, but I'm just kind of explaining it again. If you're watching this video, it's probably because you want some help with this, and so I'm going to help you. You're going to compare that arc length with the total circle length. With the total circle length, which we call circumference. And when I actually use the equation, I'll put in the formula for circumference. And so we compare the arc length to the total circle length. That ratio of arc length to total circle length equals the same ratio of degrees of the arc, or of this region here bounded by the arc, to degrees of the whole circle. And so we can see this is 90 degrees, and the whole circle always has 360 degrees. So it's like one side of our equation is all about the degrees, and the other side of our equation is all about the lengths. So don't mix them until you cross multiply. Alright, so let's go ahead and plug this in. We don't know the arc length. I'll just call it AB. But the circumference is 2 pi r, so 2 pi 7. That's going to equal 90 over 360. Okay, and so then we cross multiply. So 360 times the arc length AB equals 2 pi 7 times 90. Now, the original directions did say to give both an exact answer and approximate. So although this will be a little bit more difficult, we can do this. When I multiply 2 pi 7 times 90, I'm going to multiply all of that except the pi. So I'm going to multiply, I'll rewrite it, show you what I'm saying. I'll multiply 2 times 7 times 90, and then I'm just going to put the pi on the end. So when I do that, I get 1,260 pi. The reason why I'm doing that and not just typing it all in is that way I can get an exact answer that's even closer to the real answer. Well, it is the real answer. So now, to get the arc AB by itself, I can divide by 360. That way, AB will be by itself. I'll divide the other side by 360. So I can actually type that in, 1260 divided by 360. And I get 3.5. So the exact answer here, without rounding, would be 3.5 pi inches. Now, if I told you to go and walk 3.5 pi inches that way, I don't know if you'd really get a sense for how far that is. So we will also round this. And so you can just type in 3.5 times pi and round to the nearest tenth. I get 10.9955, so that would round up to 11.0. I'm going to put the 0.0 there, though, to show that it did not come out evenly. All right, we're going to do number 6 pretty much the same way. We have the arc length of AB, which we don't know, so I'll start with that. And we're going to compare that to the circumference of the circle, 2 pi 6. So that ratio is equal to the ratio of the degrees, 120 over, there's always 360 degrees in the circle. So if I cross multiply the 360 and the AB, those will go next to each other. And then I'm going to cross multiply the other two, 2 pi 6 and 120. But again, I'm going to do the same strategy where I just multiply 2, 6, and 120 and leave the pi as just pi. I get 1,440 pi. And so I'll divide by 360. And 1440 divided by 360 comes out to 4. So my exact answer for the arc length of AB is 4 pi feet. It's kind of nice. I didn't have to mess with any decimals around or anything. But 4 pi might not be a practical answer for you, so I also want you to write it out. As an approximate answer. So just enter 4 times pi into the calculator. Rounding, we get 12.6 feet. Okay, on to number 7. You can see this one's different. We are given the arc length from the beginning. We know it's going to be 18 pi over the circumference. What's the circumference? That's what we don't know. And so we're going to have to find the radius. When I put down the circumference formula, it's 2 pi r. So r is what we don't know. We do know this is 90 degrees out of 360. Again, we're going to try to not round with this until the very end. So on one side, I can do 2 pi r times 90, but I'm only going to multiply the 2 and the 90. Those are the only numbers that I can actually multiply. So 2 times 90 is 180, and I'm just going to leave the pi and the r there. On the other side, 18 pi times 360, I can actually multiply 18 times 360. I get 6,480, but I'm just going to leave the pi on the end of that. So now, ultimately, I want to get the r by itself. You might be able to see that the pi is going to go away when I divide both sides by pi. So it's kind of nice. I didn't even have to mess with that pi. And now we're just dealing with regular integers. So to get the r by itself, I'm also going to divide by 180. So 6,480 divided by 180 comes out evenly to 36 inches. So this radius is 36 inches. All right, and we're going to do the last one the same kind of way here, except I guess this is one where I've looked ahead and said that it's not practical to try and keep this as an exact answer. So we'll just go ahead and round with this one. But I'm going to set it up the same way. I'm going to do everything else the same. So I know this is 19.71 of an arc length, and I'm going to compare that to the whole circle length, which is 2 pi r. And I don't know the r, that's what we're trying to find. On the other side of this, I know 55 degrees out of 360. So I can do 19.71 times 360. In fact, I don't even need to round there because I don't have any irrational numbers, so I would get 7,095.6. On the other side, when I cross multiply those, I'll do the 2 times 55, that's 110, and I still have the pi r. And so to get the r by itself, I would need to divide by both 110 and pi. And so this is where I could say that r equals 7,095.6 divided by 110 pi, but that's kind of impractical. That would be the exact answer. I mean, this would be the exact answer. I suppose you could actually divide this by this, but let's go ahead and just type that in. And when you type that in, if you did it like I'm doing it, you'll need parentheses on the bottom. When you divide by more than one thing, your calculator doesn't know that you're dividing by more than one thing unless you put parentheses. So I'm going to enter in 7095.6 divided by parentheses 110 pi, close parentheses. So rounding at the very end here, I get 20.5 centimeters. Okay, now let's move on to area. The first page of this review is all about circumference and length. This page is going to be about area, including questions where we just figure out a small area of a circle, not the whole thing. So our formula for area of a circle is pi r squared. And just like on the previous page, we're going to give both the exact and approximate answers. Okay, so number 9. Pi r squared is just pi 6 squared. Now don't leave that as your answer. We can do a little bit more. 6 squared is 36. So our area is 36 pi square inches. That would be the exact number. You can also type that into the calculator to get the approximate area. You'd get 113.1 square inches. Make sure you're using correct labels. Okay, next one. Notice we're given a diameter here. So the first thing you got to do is split that diameter in half. 24.8 divided by 2 is 12.4. That is your radius. So area is pi r squared. Pi times 12.4 squared. Well, you can do 12.4 squared without rounding. We get 153.76. And then the pi stays there. So our exact area is 153.76 pi centimeters. Now, if you actually multiply that by pi and round, you get approximately 483.1 centimeters. And both of these should be centimeters squared as they are area. It means that you could fit a little more than 483 1-by-1 squares inside this circle. Must be a pretty big circle. Okay, now with these next ones, we're not figuring out the area of the whole circle, at least that's not our main point. We're figuring out the area of the sector, the shaded region. And this is going to be set up very similar to when we found the arc length. On one side of the equation, we're going to compare the sector area, that's the area inside here, to the whole circle area. That ratio is going to equal the number of degrees in the sector degrees, compared to the whole circle degrees, which is always 360. So that's the format you're going to follow. So I don't know the sector area. If you want, you could call it x. I don't know the circle area right off the top of my head, but I can figure it out pretty easily. It's pi r squared, and since r is 6, it's going to be pi 6 squared. And then this is 90 degrees, we can see, out of 360. Okay, again, we're going to try not to round until the very end with this. We'll cross multiply x times 360, or I'm going to write it as 360x. And on the other side, I can actually multiply 6 squared times 90, and I get 3,240. So write 3,240 pi. And then we'll divide by 360. And so my exact answer is 9 pi. Sometimes there's some simplicity leaving it as an exact answer. 9 pi centimeters squared. And so the approximate answer, if I actually type that in, I get 28.3 centimeters squared. Alright, same kind of question with number 12. We want to figure out the area of that sector. I don't know what that is, I'll call it x. Notice that we're given the arc measure of 60 degrees. We studied in the last chapter, in chapter 10, that this inner angle will also be 60 degrees. That'll come up. So, setting this equation up, we have the sector area. That's what we don't know. I'm calling it x. And we're going to compare that to the whole circle area, pi r squared, or in this case, pi 10 squared. And then that ratio is equal to the number of degrees of the sector compared to the degrees of the whole circle, which is always 360. All right, cross multiply, 360 times x. Cross multiply on the other side, but don't actually type in pi, just use the numbers, and we get 6,000, and then pi is just multiplied by that. And so we'll divide by 360. This way we'll be able to get an exact answer. When I divide that, I get 16.6 repeating, and then we still have the pi along with that. So you could leave your answer like that. I suppose you could also say 16 2/3 pi, although that's kind of weird to have a mixed number with something after it. So I'll just leave it like that. I believe the answer key says 16.7 pi, and it's kind of weird. It's like it's rounded and exact at the same time. So this is actually a better answer than what the answer key says. So if you still have that number in your calculator, just press times pi, and we get about 52.4 square inches. All right. On to number 13. Okay, we got to figure out what's going on with this one. Look at these little symbols in here. You might be able to realize that that means that all three of these angles in here are the same. So if you take 360, because we know they all add up to 360, divided by 3, you get 120. So all of these angles are 120. So when I set up my equation, one side of it is going to say 120 over 360. On the other side is this sector area, which I don't know, divided by the whole circle area, which is pi r squared. And look, they're giving us the radius of 24, so pi 24 squared. All right, cross multiplying, I'll have 360x. And on the other side, I need to do 24 squared times 120. I get 69,120 times pi. And then we'll divide by 360. And that comes out to 192 pi. So the exact area of that shaded region is 192 pi square feet. If you actually multiply it by pi and round, we get 603.2 square feet. And number 14. Okay, and number 14, we don't know the area of the shaded region, so I'll call that x. And we're going to compare that to the area of the whole circle, pi r squared, or in this case pi 8 squared, since that's the radius. And then we're going to compare that to degrees. It'll be 60 out of 360. We know the central angle of an arc will match the actual arc measure, so that's going to be 60. All right, cross multiplying. 360x on one side. On the other side, I'm going to do 8 squared times 60, but leave the pi, so it's going to be 3,840 pi. And then divide by 360. And that comes out to 10.6 repeating. I'll do what I did on the other one and just leave it as 10.6 repeating pi square inches. That would be the exact answer. If I actually take that times pi on my calculator, and rounding, I get 33.5 square inches. All right, the next four problems are all from lesson 11.6. This was actually the lesson that we spent 2 days on because it was difficult. This is one of the most difficult lessons of the chapter, maybe even of the semester. It's doable, but it just takes time. To find the area of a regular polygon, we're going to use this overall formula. Area equals 1/2 A times P, and that's in your theorems formulas packet. A is the apothem, and P is the perimeter. We'll review those. Okay, so let's start with number 15. First of all, this is a hexagon. It has 6 sides. So what we're going to do is we're going to make a triangle from the center. You can see one side is already drawn in. If I draw this side in, you can see a triangle. And if I really wanted to, I could draw in 6 triangles. Since there are 6 sides, one side each creates a triangle. And so the reason why I bring that up is because if I divide 360 by 6, I get 60. So each one of these triangles would have a central angle right here of 60 degrees. So what I'm going to do to figure out perimeter and area is I'm going to drop a perpendicular height line down that triangle. That line is actually the apothem. The apothem is the distance from the center of the shape to the side measured perpendicularly. That's the official definition. I'm usually going to think of the apothem as the triangle height when you form a triangle, because that's what we're going to do in all of these problems. So here's what I'm going to do with this. This triangle is kind of small. I'm going to redraw it outside, but I'm actually only going to draw half of it, the right triangle part of it. And so because I'm splitting that 60-degree angle in half, I'm only going to have 30 degrees. I know that this side is 8 right here. And so I need to figure out the apothem A. We're going to need to use some trigonometry, some sine or cosine or tangent. It might help you to write out SOHCAHTOA. And so we're going to be looking at this from 30 degrees point of view. From 30 degrees point of view, we have the adjacent and the hypotenuse. So which function uses adjacent and hypotenuse? It's cosine. So cosine of 30 degrees equals adjacent over hypotenuse. So for us, adjacent is A, hypotenuse is 8. A over 8. And so then, to get A by itself, we'll multiply both sides by 8. Now, this is not going to come out evenly if I type it into my calculator, and this is not the final answer. So I would suggest just leaving it as 8 times cosine 30 for now. This is not our final answer. I'm going to circle it, though, so I can find it and come back to it. Remember, we are using the overall formula 1/2 apothem times perimeter. So this is the apothem part of that. Now we just need to figure out the perimeter. So going back to our triangle here, the number that is here is going to be part of the perimeter. It's not the whole perimeter, so I'm not going to call it P. You can call it X, or I'll just call it B. What if we want to figure that value out? Well, from 30 degrees point of view, this is the opposite, and this is the hypotenuse. Which one is opposite over hypotenuse? That is sine, opposite over hypotenuse. So I'm going to set this up as sine of 30 equals opposite, B, over hypotenuse 8. Now we'll have to multiply both sides by 8 to get B by itself. And again, that's not going to come out evenly. So for now, I'm just going to leave it as 8 sine of 30. That's the distance of what I'm calling B from here to here. So if I look at that in our bigger triangle, B is this distance from here to here. See how that's not really the perimeter, it's just a very small part of the perimeter. So let's times that by 2 so we can get one whole side length. So I'm going to figure out what 2b is. So times it by 2 and I get 16 sine of 30 degrees. So that is the length of one side. I'm just going to make a little note here. So that's one side length. Now how many sides are there on this shape? This is a hexagon, so there are 6. So if I want the whole perimeter, I'm going to have to take 6 times that side length of 16 sine 30. I can actually multiply 6 and 16. I get 96. And so that is my perimeter. Alright, now the directions did say for this problem to find the perimeter and the area. We had to find the perimeter because it's part of the area formula, but I suppose since this is one of our final answers, we should actually multiply this out. So if you type in 96 times sine 30 into your calculator, actually this one works out evenly. That's very convenient. The perimeter is 48 inches. So now, let's set up our final area formula where we do area equals 1/2 apothem times perimeter. Area equals 1/2. Our apothem is there, 8 cosine 30, times our perimeter is there, 48. Or if 48 had not come out evenly, I would be writing 96 sine 30 degrees. But it did come out evenly, so might as well use that. Now I'm just going to type this into the calculator basically as is. I'm not going to type in 1/2. I'm going to type in 0.5 instead. But if you type that in, 0.5 times 8 times cosine 30, what you'll want to do is close the parentheses in the 30. The calculator automatically opens one, so make sure you close it, and then times 48. And so we are going to round here at the very end of the problem. Our area is approximately 166.3, and that is square inches. Okay. You know, I suppose if we really wanted to, I mean, that'd be the answer, that'd be fine. But if we wanted to, if we just multiplied the 1/2 and the 8 and the 48 all together, we could get an exact answer. It would still have the cosine 30 in it, because that doesn't come out evenly, but 1/2 times 8 times 48 is 192. So 192 cosine 30, I suppose that would also be acceptable. But it does say round to the nearest tenth, so that's fine also. Okay, so you can see why this is one of the more difficult things that we're doing this chapter in this semester. It took some work to do this, and you should be showing this work. This is not optional to show. This is work that you should be showing. All right, let's do number 16. Okay, 1/2 apothem times perimeter, and what I want you to realize here is if you draw your triangle, look what they gave us. They gave us the apothem of 4.5. So right away I know this is going to be 1/2, or 0.5, times 4.5 times the perimeter. I don't know what the perimeter is, so that's what I'll have to figure out. This is an octagon, so if I do 360 divided by 8, because really there could be 8 of these triangles that I could draw, each one with its own angle, but 360 divided by 8 is 45. So that would mean this angle in here, that whole angle, is 45 degrees. But just like I did the last time, I'm going to recreate the triangle outside so I can kind of enlarge it. Well, now I got to split that 45 in half, so it's going to be 22.5 degrees. I know my apothem is 4.5. I know this is a right triangle. What I don't know is this distance right here. That's going to help me get the perimeter. Like I did in the last one, I'll call that B. You could call it X or whatever letter you want. Maybe don't call it P because it's not the perimeter, it's just a part of the perimeter. Okay, so how could we figure out what this value is? Well, I don't have the hypotenuse and I don't really care about it, so which function only has adjacent and opposite? That would be tangent. So if we set this up, tangent of 22.5 equals opposite over adjacent, b over 4.5, and we'll just multiply both sides by 4.5, and so it'll say 4.5 times tangent 22.5. Okay, now that is only this little distance from here to here, if you can see that. So if I times it by 2, and get 2b, that will at least give me the side length. So 4.5 times 2 is 9. So 9 tangent 22.5, that will give me a side length, but since there are 8 sides, the whole perimeter is going to be 8 times 9 tangent 22.5, and 8 times 9 is 72. So my exact value for perimeter would be 72 tangent 22.5. I don't think this one's going to work out evenly. If we are supposed to give kind of a rounded answer for this, I can do that. I can type that in, and I get approximately 29.8 centimeters. Alright, so now let's go for area. We have the apothem, we have the perimeter. So area equals 1/2, or 0.5, apothem times perimeter. Now, rather than use this rounded value here, why not just use the original perimeter, the one that is our exact answer? That would be the best thing to do. So that would be 72 times tangent of 22.5. I can kind of squeeze it in there. Now if I just multiply all the numbers here on the outside 0.5, 4.5, 72, I get 162. So I suppose my exact area is 162 times tangent of 22.5, but it would probably be practical to just round that and get an approximate answer of 67.1 square centimeters. Again, remember what area means. If you take 1 square centimeter, that's 1 by 1. What this answer is saying is you could fit 67 of these, a little more than 67 of these, inside this shape. They would all add up to 67 and 1/10 square centimeters. Okay, we got a couple more of these. Like I said, this is not easy, so it'd really help to practice this. Okay, look, here's another one where they're basically giving us the apothem. What kind of shape is this? Let's count the sides. 1, 2, 3, 4, 5, 6, 7, 8, 9. A nonagon. So if I do 360 divided by 9, that equals 40. So that means this whole angle in here is 40. Each of the 9 triangles would have an angle of 40. So when I draw my own little right triangle outside here, I got to split that in half, and so that top angle is 20 degrees. I know this is a right angle. I know the apothem is 2.5. What I don't know, this is another case where I don't know the perimeter number. So I'll call this B. That's what I've been doing. You can call it whatever letter you want, maybe not P because it's not perimeter. And so again, just like number 16, I can use tangent. Tangent of 20 degrees is opposite over adjacent, so B over 2.5. If you multiply both sides by 2.5, you just get 2.5 times tangent 20. So that is not the whole perimeter. That is not even one of the side lengths. It's half of a side length. So if I multiply it by 2, I'll get an entire side length. So 2.5 times 2 is 5, and I still have this tangent 20. That's one side length, but since there are 9 sides, I need to take that times 9. So 9 times 5 tangent 20 is 45 tangent 20. That would be the exact perimeter. If I type that in my calculator, I get 16.4 rounding. I would get 16.4. So I suppose my answer for perimeter is 16.4 feet. But now I can figure out the area. I have the perimeter. I already had the apothem to begin with. So the area is 1/2, or 0.5. The apothem is 2.5. And the perimeter, again, use the exact value perimeter. 45 tangent 20. If I wanted to leave this as an exact answer, I could just multiply the 0.5, 2.5, and 45. And I get 56.25. So 56.25 tangent 20. That's the exact answer. That might not be very meaningful to us, though. It'd probably make more sense if we actually multiplied that by tangent of 20 and got 20.5 square feet, approximately. It means we could fit 20.5 1-by-1 squares within that shape. All right, number 18. Let's see here. Is this the apothem? No. If I draw a triangle, 4 is one of the side lengths. 4 would also be the other side length of the triangle. So what I need is this line that splits the triangle in half into a right angle. This is a hexagon. I think we did a hexagon earlier. If you divide it by 6, you get 60. So this central angle here is 60 degrees. If I split that in half like I've been doing, then I have a hypotenuse of 4. This angle will now be 30 degrees because I split it in half. and I don't know the apothem. I don't know the perimeter either, but I'll figure out the apothem first. So I can use a sine or a cosine or tangent to do this. I am given the adjacent and the hypotenuse. So adjacent and hypotenuse is cosine. So I'll start off with cosine of 30 degrees equals adjacent over hypotenuse, a over 4. Multiply both sides by 4, and you have 4 cosine 30. And I'll just kind of leave it like that for now. I'm going to come back to that. Let's talk about perimeter. Perimeter would relate to this value along the bottom part of the triangle. I'll call it B, like I have been. And so to do that, I could use sine. Sine of 30 is opposite over hypotenuse, so B over 4. And multiply both sides by 4, and B equals 4 sine of 30. Now, that is just one little part of the triangle. If I multiply it by 2, I'll have 8 sine of 30. And that will be the whole side length. But since there are 6 sides, I could multiply that by 6. So 6 times 8 sine of 30. And actually putting that together, that would be 48 sine of 30. And so if I actually type that into my calculator, it comes out evenly. 24. That's kind of nice. You notice it often does that in a hexagon. So this perimeter just equals 24 inches. No rounding required. Well, now I have what I need to figure out the apothem. Well, I already figured out the apothem. The area, excuse me. Area equals 1/2. Apothem is 4 times cosine of 30 times the perimeter, 24. If I wanted to get as an exact answer as possible without rounding, I could multiply the 0.5, the 4, and the 24 together, and I would get 48. So I could say area is 48 cosine 30. But we'll go ahead and round that. 48 times cosine of 30 is 41.6 approximately. And that would be square inches. So when you're doing these problems, just make sure to show your work so I can follow, so you can follow, and give you all the points you deserve. If you show your work and you get the right answers, you'll get the full points. If you show your work and don't get the right answers, I might be able to give you some credit still. I can look back at what you did. If you at least started it right or knew some part of it, maybe you could get a quarter credit or half credit. And if you made just like a little mistake, you might even be able to get like 3/4 credit, even though you got the wrong answer. So just keep that in mind. All right, the very last lesson that we studied is on this page, lesson 11.7, and it's all about geometric probability. The probability that if you pick a point randomly, what are the chances that that point would be selected out of a total? So we'll start off with a number line example. It says, find the probability that a point K selected randomly on the line AE is on the given segment. Express your answer as a fraction, decimal, and percent. So the first thing I would do is figure out how long is this total segment we're talking about. If it's on AE, that goes from -8 to +8. That's a total length of 16. So when we do the first example, we're saying, what's the probability that a random point you pick somewhere on here, could be a whole number or an integer, could be a fraction, what's the probability that it's going to be on BC? Well, BC has a length of 6. So our basic probability is 6 out of 16. There's a 6 out of 16 total chance that's where the point will be selected. So let's reduce that fraction. 3/8. And we can also do that as a decimal. If you divide 3 divided by 8, we don't even have to round here. That just equals 0.375. And often probability is expressed as a percent. Remember how to change from decimal to percent? You take the decimal point and you move it over twice. So as a percent, it would be 37.5%. I want you to be able to write down all 3 answers. All right, here is another one. BD. Where is BD? BD is from here to here. How long is that segment? Well, It's 6 to 0, and another 4 makes 10. So we would have a 10 out of 16 chance. And reduce that, and you get 5/8. And 5/8 is a decimal. If you do 5 divided by 8, you get 0.625. If you move the decimal place over twice, you get 62.5%. That's the probability that if you know you're going to pick a point between A and E, that the point will land between B and D. All right, let's look at number 21. CE. So what's the probability that it's going to land on CE? Well, you can see that CE is 8 long. So 8 over 16, that's 1/2, or 0.5, or 50% chance, right? That makes sense. That segment takes up half of the total, so there's a 50% chance that it will land there. All right, and lastly, for this set, we have AD. AD. Okay, how long is that segment AD? Well, it's 8 to 0, and another 4 makes 12. So 12 out of 16, if you reduce that, you get 3/4. You might know what 3/4 is as a decimal. If not, go ahead and just divide. 3 divided by 4 comes out to 0.75, which would be 75%. So that is the basic idea.